So good day, everyone. So let us move to the next chapter in physics. So the next chapter in physics is a simple harmonic motion. Some people they call it was SHM. See, if you look at simple harmonic motion, it's a periodic what? Motion. So it's one of the type of motion we have. So definition XHM can be defined. This is the definition for simple harmonic motion. So I said it can be defined as a periodic motion of a point along a straight line such that its acceleration is always toward a fixed point in that line and is proportional to the distance from that point. That is what? As a what? Acceleration. And what are the examples of acceleration? An example of simple harmonic what? Motion. Number one, we have simple pendulum. Number two, we have compound pendulum. Number three, we have loaded test tube in liquid. Number three, we have mass on a string, loaded mass on a what? On a string. So these are the four common examples of what? Of simple harmonic motion. The next thing is what? Let us look at the what? The graph of SHM. Graph of what? SHM. See, the graph of SHM is sinusoidal curve. It's a sinusoidal what? Curve, because simple harmonic motion is a periodic what? Motion with regular what? Interval. So the graph of what? Of simple harmonic motion is a sinusoidal what? Curve. That is a curve that is what? Is moved up and what? Down with regular time what? Interval. And the graph of SHM can be determined by plotting what? Distance or displacement y against what? Against time. So let us look at the curve of SHM. The graph for SHM is this. We have this is what? Displacement y displacement against what? Against time. Time in what? In seconds. And I said the graph is what? Is sinusoidal curve. It starts from the origin. It moves up like this, come down, up, come down, and what? Up. So if you look at what? This graph, this is time in what? In seconds. This is what? Displacement in what? In meter. And here is origin. So this place is what? Is crest. Crest. The distance between this and this, we call it what? A, which is amplitude. Amplitude. So, and here we have, let me put it in this form. This place here, let me call it what? This is period. So this is the what? Graph of what? Simple harmonic what? Harmonic motion. And I said the graph can be what? Obtained by plotting displacement against what? Against time. And the equation of the graph is y equal to what? A sine what? Theta. That's the equation of the graph. The y equal to the what? A sine what? Sine theta. You can call this equation what? Equation 1. And if you could still remember in circular motion, this theta is known as what? Angular what? Difference. Abi, can I say what? Recall that theta is omega t. Substitute for theta here. We have y should be equal to what? A sine what? Omega t. This is what? The equation of what? Of the graph. So we obtain this graph from where? Distance against what? Against time. And the next thing we need to check is yet from this graph. Let us determine the amplitude. Amplitude A. This is amplitude, this is amplitude, this is amplitude. So the maximum displacement of a wave is known as what? Amplitude. And it is measured in what? In meter. So this amplitude A is what? The maximum displacement of a what? Of a wave is called amplitude. The distance here is called amplitude. Distance from here to here is called amplitude. From here to here is amplitude. From here to what? Amplitude. And if you look at this graph, it's a free oscillation curve. So the graph have the same amplitude. So the maximum displacement of a wave is known as what? As amplitude, and it's measured in what? In meter. The next thing we need now is what? Is period. Period T. What is the period of a wave? Or of the wave? The period is the time taken to complete one oscillation. The time taken to complete one oscillation is called what? Period. If I said one oscillation, one what? One oscillation means what? One cycle. What do I call it? One cycle. So the time taken for a wave to complete a one cycle is called period. If you look at this now, from here to here, this is half of circle, abi? This is semicircle now. Then from here to this place is another what? Circle. This is half of circle, this is also half of circle. Abi now? From here to here, half of circle, this is another half of circle. If you combine them together like this, this half of circle, put this one here, it will form a what? A circle. So the time taken to complete a one circle is called period. What is the period of this curve now? Mistake. This is one what? One cycle. So look at this place now. From this particular point here to this point, you can also call what? Another what? Another cycle. You can see it now. So the time taken to complete one oscillation or to complete one cycle from here to this place is called period. So time taken to move from this point to this point is also called what? Period. That is what? The period of oscillation. The next one is what? We have frequency. frequency f. So the frequency is the number of complete oscillation per second. The number of complete oscillation per second is called what? Frequency. The number of complete oscillation per second is called frequency, and the frequency is known as what? Is 1 over what? T. And it is measured in what? Per seconds as unit. So this is the formula for frequency, this is formula for period, this is formula for amplitude. Once again, amplitude is what? Is the maximum displacement of a wave. The period is what? Is the number, or is the time taken to complete one circle, or the time taken to complete one oscillation is called period, but the frequency is the number of oscillation in 1 second, or per second is called frequency, and is 1 over what? Over f. Let us solve this question now. Solution. You have what? A simple harmonic motion is represented in SI units as y equal to what? 0.08 sine angle of 0.400 pi t. What are the amplitude? Amplitude A, unknown, and the period of the motion, and t is also what? Unknown. Yes, this is equation 1, equation 2. The formula for period here, let us call it what? Equation 3. The formula for frequency here, let us call it equation what? Equation 4. Good. So we are now asked to find the what? We are given this equation. We are asked to find what? The amplitude and period. What we do now? What is the general equation for simple harmonic motion? I said it can be represented by what? A equal to the what? Y equal to A sine theta, amplitude and the angular difference. So where angular difference is what? Is omega t, we put it here, Abi. So you can now write your equation from general equation of what? This y equal to what? A sine omega what? Omega t. This is the general equation of simple harmonic what? Motion, SHM. Let us compare this what? This equation with the given equation here. A here is amplitude, Abi. This is y, this is equal, and this is A. You can find A at the back of sine. What do you have at the back of what? Of sine A is 0.08. Therefore, our amplitude is what? 0.08 meter. Just compare the two equations together. We have y, this is y, this is equal. We have amplitude A here at the back of sine. What at the back of sine here is 0.08. This is your what? Your amplitude. Abi, and this is sine. Abi now. The next thing we have now, after sine, we have omega t. Abi, what do we have there? Is 0.400 pi t. Abi now, 0.400 pi t. Automatically, you will know that what? Yeah, this is t. Everything we have at the back of t here, pi 0.400 equivalent to the what? Omega. We now have what? Your omega should be equal to what? 0.400 pi. This is omega. By comparing the two equations together. Abi now? Yes, we are looking for what? For period. And if you could still remember, under circular motion, we know that period t equal to the what? 2 pi or what? Omega. If you check under circular motion, what? The period of circular motion is equal to the what? 2 pi omega t. And what is the omega given here? Our omega here is what? We have t, 2 pi, we have 0.400 pi. This pi cancel this pi. No be so. The next thing is what? We have t, period t should be equal to what? 2 over 0.400. By applying the calculator, the period it will give us what? 5 seconds. Therefore, the period T is what? 5 what? 5 seconds. I believe you get the solution. So the next thing is what? Let us move to velocity in simple harmonic what? Motion.